All right, everybody, we're going to do a Zoom review, and we're going to start with a retrosynthetic analysis from fall 21. Yes, we have these on every test. And what do you do to start? Well, the important thing is to find a functional group that you know how to make. And I see right in the middle here, and you will see on your exam next Monday, an ether. It's important to remember how to make ethers. The simplest and most straightforward way to make ethers is the SN2 reaction, also known as the Williamson ether synthesis. But we just need to figure out what's the best possible SN2 reaction to make this ether. And if you remember, SN2s work best if a primary carbon has a leaving group. They slow down if it's secondary, and they don't happen at all if it's tertiary. So, which of these two carbons in your ether is primary? Answer, this one. That's the carbon that needs to have the leaving group. This is the bond that you will make in the last step of your synthesis. You need a leaving group on the carbon, and you need an O- nucleophile to make the ether. And there we go. So far, so good. Now the question is, how do I make these two target molecules? Yeah, you have new targets. This can be made from an alcohol. Anytime you see a halogen, it could be made from an alcohol. So let's get something going here. Try to draw a nice retro arrow. That's not a bad one. It comes from an alcohol. Okay. Now, is this the end of the road for these 8 carbons? And the answer is no. It's not the end of the road until you've gone down to benzyl alcohol. You're not allowed to forget what benzyl alcohol is, because it shows up on most of these retros. It's not HO attached to a benzene. No, it is not. Benzyl is the carbon one away from a benzene. So you have to get back to benzyl alcohol right there. And that has an extra carbon. So do not panic. We know how to make bonds using things called organolithiums or Grignard reagents attacking aldehydes or ketones. And after the attack, the aldehyde or ketone loses its pi bond and becomes an alcohol. So if this carbon was an aldehyde, then I know how to make this bond, as long as this is an organolithium or a Grignard. So let's show that. We have an aldehyde here. If I leave the end of those two lines, it just looks like an equal sign. So there you go. And then I have, we can use another color. Let's use pink. Grignard or an organolithium. Lithium, CH2F. Those two will combine to make this species. Step 1, the C- attacks, you get an O-. Step 2, you're going to show me during your forward synthesis. Step 2, you have to protonate your O-. Now things are happening. We're almost done with our carbons over here on the right. And the question is, where does formaldehyde come from? It's not on my list, but I'm allowed to go to alcohols of 5 carbons or less, and formaldehyde is one oxidation step away from methanol. That is a one carbon alcohol. It needs a circle. And the question is, where does this benzyl lithium come from? Well, it comes from a benzyl halogen. All organolithiums and Grignards come from organohalogens. So just put your favorite halogen there. We love BR in this class. And then this is one step away from, now let's use that one, benzyl alcohol. I hope that sounds familiar. One step away from benzyl alcohol. Put a circle on it. That's this molecule right here. Okay. All right, I think we're finished with the blue portion. We're going to talk about this green portion over here. Just remember what I said about this reacting with this reacting with this to make an O minus right here, that you need to put an H on. Well, what happens if you just want the O minus and you don't want to put the H on? Because look, I've got an O minus. I don't need to put the H on. Hey, it came from an attack on an aldehyde or a ketone, and the aldehyde or ketone carbonyl became an O minus. So we can make this bond not a good idea, because it doesn't say anywhere you're allowed to start with something that's just benzene. Here's benzene with its extra carbon. Sounds like benzol to me. It sounds like it's a good idea to make this bond. Well, I didn't really hit that one very well, did I? I know how to make that bond. And I'll be going different retro arrow here. This time we'll go light pink. And if I want to make that bond, here's what it was before I made that bond. How about, you want to stick with organolithiums all day? You can use a Grignard or an organolithium and react it with phenyl attached to a carbonyl. And that would give you that O minus. Straight up. What's the question now? Question is, where'd that come from? Where'd this come from? I got the answer for where this came from. That's one oxidation step away from a benzyl alcohol. That's what I'm saying. There you go. Put a circle on it. I know you circled it all once already over here. Circled it here, but we're using it over here in a different fashion. So now we have this 1, 2, 3, 4, 5, 6, 7 carbon fragment. And it has to come from alcohols of 5 carbons or less. There is no benzyl happening with this one, right? No. So make sure you know that lithium's part of that. Right there, yeah. Well, the only place you know organolithiums come from is organic halides. We got to know that. It's central. So just copy down the organic halide. Bromine, you want to stick with bromine all day? Why not? And you could say, hey, that comes from an alcohol and I'm done. Uh-oh. It comes from a 7 carbon alcohol and you're not done. Why? Because it's 7 carbons and you don't have any 7 carbon alcohols at your disposal. It says so right in the question. You have 5 carbon alcohols at your disposal and 1 7 carbon alcohol called benzyl alcohol. All right. So you want to make your life easy, right? You don't want to try this again and add one extra carbon. Didn't this make this bigger by one extra carbon to get to here? It did. That would take me from 6 to 7. But we know a way to get more than one extra carbon. You don't attack an aldehyde. You attack, and don't attack a ketone. You attack an, I want to have an OH here. And I want to have 2 new carbons here. So how am I going to make this bond? Right here is the question. I'm not going to draw it yet because I'm just nattering on here. That's a word nobody uses anymore, nattering. I need that to come from this. And I know how to make that with 2 new bonds. Well, 2 new carbons, 1 new bond right there. If I attack a species on 1 carbon and I'm left with an oxygen on the adjacent carbon, that language is reserved for epoxides, everybody. And before you go saying, I didn't know I'd have to use an epoxide, just look at the original question, everybody. Your answer must then use an organolithium or Grignard attacking an aldehyde, ketone, or epoxide, possibly more than once. This will be our 3rd time. We use an organolithium attacking an aldehyde here. We use an organolithium attacking an aldehyde here. Went up to here. We're going to use an organolithium attacking an epoxide to get from here to here. How many carbons in the epoxide? 1, 2. The simplest of all epoxides coming up. There you go. Just so this thing doesn't take up the whole page just for the retro. Go upwards on these 2. Organolithiums come from organic halides. It seems to me if you don't know that, you're throwing away, what, 6 points on this page? At least if you don't know organolithiums come from organic halides, and if you don't know organic halides come from alcohols, then 6 more points on this page? Yeah, those are fundamental reactions. And organic bromides come from alcohols. Oh, down there. Probably because I rotated it. Here we go. Uh-oh. Sorry, I rotated it a little more. Yellow. Alcohol, 5 carbons. Epoxides, we know how to make epoxides only from alkenes. You don't know how to make epoxides from anything else. You don't. So you got to know how to make them. And where do alkenes come from? They're not on my list. They're not on my list. Alcohols are on my list. If you dehydrate an alkene, dehydrate an alcohol, you get an alkene. So before I do the forward synthesis, here is the retro. We've accounted for every carbon in the target molecule. Every carbon in the target molecule is now circled here. And you don't have to redraw anything now. You can show me the forward synthesis on top of your retrosynthesis as long as you use the correct arrows. Some of you still like inventing your own retro arrows. No, some of you made them look like reaction arrows. What am I going to do? I was pretty nice. I just took off 1 point instead of saying none of your retros right because you use reaction arrows. These are not reactions. These are backward thinking. These are, this comes from this. Okay? Sorry, this comes from these 2. I misspoke. It's already hard enough. Let's do it again. What does this retro arrow mean? It means this thing came from this. What does this retro arrow mean right here? It means this thing came from that. Now show me how you make this thing into this thing and use a different colored arrow, I think. And it's a real reaction arrow. What chemicals are going to let me do that? Thank you. Somebody said PBr3. Let's just keep going along the right side here. What chemicals convert an organic halide into an organolithium? Yeah, we got lithium and hexane. Thank you. What chemicals? Well, let's get to here first. This is a redox. Ladies and gentlemen, anytime you're changing the number of bonds to oxygen, it's redox. That's all that's changing here. If you're increasing the number of bonds to oxygen, you better think about chromium. And you got to be careful with primary alcohols, or in this case, methanol, because you can oxidize it too much. You better use the one that oxidizes it only once. And that's PCC. Now you need to show me clearly that you know when you combine these two things, first you have to mix them by themselves with nothing else there. And then you get an O minus. You have to show me how to make the O minus into an OH. And you have to show me you know it's a second step. None of those things can be left out. All right? You can't mix this thing with HCl. You won't be around to tell the story. Anytime you mix something that's the strongest base on our list of acids and bases with something that's the strongest acid on our list of acids and bases, it's going to be the most exothermic reaction you can think of, and you made a fuel that burns. So I don't know. A lot of caution there, but here's how I do it. I say, first, I mix them. Second, I add HCl. There you go. The word mix just says mix whatever's in those parentheses. And then 2, after it's finished, add HCl. And then we're getting the same points for the same reaction again. How do you convert an alcohol to an organic bromine? Same reaction. Using it over and over. 1 point for knowing the reaction backwards, 1 point for showing me how to do it forwards. That's 2, and that's 4. Coming up again, too. It's going to be 6. All right. How do you... Well, let's not pretend we're at the end here. We don't have anything to mix this thing with yet. So let's go to the other circle and tell me how to make an alcohol. Probably best to zoom in a little bit. Probably real tiny on the video screen. How do you make an alcohol and an alkene? You've got to make it lose water. Somebody said H2SO4. That's right. Yeah, I don't think you want to add water. That would make it go backwards, right? Yeah, we don't want to go backwards. H2SO4 and heat. And then making a peroxide. We have several ways. She likes MMPP because it's nice and short. It's a per acid, per carboxylic acid. You can look in chapter 11 at the four of them that you're supposed to know, per acid, and use one of them right there. Then I'm going to take, well, I can't mix these things together yet because I haven't made the organolithium. But when I do mix them together, they're going to make this. And once again, you have to mix them first, and then you're going to get an O minus. Whoa, I went the wrong direction. The thing doesn't point up there. What am I doing? X. The thing point. Whoa. Sorry, I got to be careful here. There, we're going to there. This thing comes from these two things. They need to be mixed, and then HCl needs to be added. And this mixes with this to make this. We need to make this piece so I can react with this. I never did that. Like I promised, points 5 and 6 here. You already got 0.5 for saying you know how an alkyl bromide comes from an alcohol. You already told me how to do that. That's right. You already told me you knew you could do that. Here's how you do that. PBr3. How do you make an organic bromide into an organic lithium? Somebody already told me that one. Yeah, lithium hexane. There you go. Then you mix NaHCl on those, and then you've got to make that into, well, I think I lied to you. You're getting 8 points for alcohols and organic bromides. It's the 4th time we've used this, I'm pretty sure. And a lot of stuff the same. And then we can finish it off. They're going to mix these two together. I don't even think you have to put mix because you're not doing the HCl step. You're skipping it. I need the O minus. Sure, you could put the H on, but then you're going to have to take it off. I've got the O minus. It's ready for my SN2 reaction. You just have to say mix those two together to do this. You want to show off, you could put a nice SN2 solvent in there. Yeah, it's showing off. You don't need points for solvent. You don't get points for solvents on the retro. But maybe something like DMSO or dimethylformamide, which is DMF, or acetone, or acetonitrile, our favorite SN2 solvents from chapter 9. Okay, and that's the whole retro right there. We'll see if the video worked out. It's our first one, I think, in this room.